How long will the first Proxima Centauri mission last? The closest star to our solar system is Proxima Centauri. Still, it is so far away that it would take us tens of thousands of years to reach it with existing technology. But if any space travel technology is capable of producing a ship that can leave the solar system and travel to the stars, how much time would it take us to get to Proxima Centauri? What kind of spaceship would that be, and who would be on board? Let us investigate. It is critical to comprehend certain information about Proxima Centauri. This star is 4.24 light-years away from our Sun, implying that light from there takes more than 4 years to reach Earth. It's a red dwarf star, which means it's much smaller and cooler than our Sun. Its radiance is so feeble that it cannot be seen with the human eye, even from the furthest depths of space. Despite this, Proxima Centauri's vicinity makes it an appealing target for space research. The length of the journey is determined by various factors, including the technology available, the speed of travel, and the amount of time people can stay in space before returning. We have currently dispatched a spacecraft at a speed of roughly 200,000 kilometers per hour, which is only 0.02% of the speed of light. To reach Proxima Centauri in an acceptable amount of time, we would need to build technology capable of significantly faster speeds. Nuclear propulsion is one of the conceivable possibilities. This technology would generate a great quantity of momentum and speed using nuclear power, allowing the spaceship to travel far quicker than it does now. However, this technology is still in its early stages of development, and it is unclear whether it will be ready for a human-crewed voyage anytime soon. Another possibility is laser propulsion, which employs laser beams to move a spaceship at breakneck speeds. In laboratory experiments, this technology has proven to be effective, and it could be a realistic choice for a future human-crewed voyage to Proxima Centauri. However, additional testing and development are required before it can be utilized on an actual mission. Once the propulsion system is chosen, the trip time to Proxima Centauri will be determined by the distance the spaceship must go. Although Proxima Centauri is the nearest star to us, it is still a long way away. It would take us more than 6,000 years to get there at present spaceship speeds. Generation ships. A generation ship is a spaceship that is built to house numerous generations of humans. Rather than attempting to go to Proxima Centauri in a single journey, the generation ship would allow astronauts to live and work in space for decades, if not centuries, while en route. Astronauts on a generation ship would spend their entire lives in space, raising families and maintaining the spacecraft. The journey to Proxima Centauri would take several generations, but it may be the only viable means to approach the nearest star in the foreseeable future. The concept of a generation starship has numerous obstacles. One of the most pressing issues is environmental preservation. Life in space can be monotonous and demanding, and astronauts require a safe and comfortable environment in which to live and work for decades or centuries. In addition, the spaceship would have to be self-sufficient in terms of food, water, oxygen, and power. Another challenge is the astronaut's health. Humans are not built to live in space for extended periods of time, and astronauts can suffer from a variety of health issues, including bone and muscle disorders, cardiovascular illness, and mental health issues. To allow astronauts to live and work in space for decades or centuries, significant medical improvements may be required. Taking all of these issues into account, a human-crewed journey to Proxima Centauri aboard a generation ship may last several generations, if not centuries. Despite the fact that it may appear to be an impossible mission, space exploration has always been a challenge and an incredible feat. If all of the problems and potential answers are considered, we may be able to attain this goal in the future. Some fiction ideas. There are various works of fiction that have addressed the subject of a generation ship, such as Interstellar, 2014 film. Christopher Nolan directed the film. The Cooper generation ship in Interstellar is characterized as a massive spaceship capable of carrying thousands of people on a long journey to a new home. The starship is meant to run on advanced technology that allows for interplanetary propulsion, onboard agriculture, oxygen and water production, and renewable energy generation. The ship is a gigantic construction made up of numerous spinning rings linked together by bridges. These rotating rings are required to provide artificial gravity and let crew members to live and work on board comfortably. The ship also has a sophisticated communication system that lets crew members to communicate with Earth and other spacecraft. In terms of the viability of constructing a generational ship like Cooper in real life, it is vital to remember that we do not have the capability to construct a ship of this scale and complexity. To build a generation ship, considerable breakthroughs in interplanetary propulsion technology, power generation, food production, and space engineering technology would be required. However, some experts believe that with adequate finance and resources, a generational starship may be built. Aurora, 2015 novel. This science fiction novel by Kim Stanley Robinson depicts the narrative of a generational spacecraft named Aurora that goes to a distant star in quest of a new home for humanity. The novel delves into the crew's technological, social, and psychological obstacles as they attempt to survive in a restricted space. In Kim Stanley Robinson's novel of the same name, the generation starship Aurora is portrayed as a smaller ship than Interstellar's Cooper, with roughly 2,000 people on board. The ship is planned to move at 10% the speed of light, which would take it 150 years to reach its goal. The Aurora ship is a hollow cylinder divided into two portions by a spinning ring that creates artificial gravity. The ship's upper half houses the food production and crew housing, while the lower section houses the engines and life support systems. Concerning the viability of constructing a spaceship like Aurora in real life, it is important to highlight that we still lack the necessary technology to construct a generation ship capable of traveling at 10% the speed of light. Interstellar propulsion is still a big barrier in space travel, as we do not presently have the technology to drive a spacecraft at these speeds. However, with sufficient funds and resources, creating the technology required to construct something like this may be conceivable. Most promising technologies, solar sails and pulsed nuclear propulsion, are two propulsion systems that could be employed on the first human-crewed voyage to Proxima Centauri. Both offer benefits and drawbacks that must be evaluated before selecting the best technology for the objective. Solar sails are a type of propulsion that employs the pressure of the sun to propel a spaceship. A solar sail is a big, lightweight structure made of reflecting materials that absorbs solar energy and uses it to propel the boat forward. Because the solar sail does not require fuel, it is lighter and more cost-effective than conventional propulsion techniques. The solar sail, on the other hand, is better suited for long-distance exploration missions that do not require high speeds. In addition, the solar sail must be exposed to sunlight in order to function, which can be difficult in deep space. The energy released by a controlled nuclear explosion is used to accelerate a spacecraft in pulse nuclear propulsion. A little amount of nuclear material is used in a controlled explosion to propel the ship forward. Pulse nuclear propulsion is one of the most efficient modes of propulsion, capable of propelling a spacecraft to incredible speeds. However, because to the nature of nuclear technology, it also poses substantial dangers and safety concerns. Although both methods have advantages and limitations, it is likely that various propulsion technologies will be deployed concurrently for the first human-crewed voyage to Proxima Centauri. For example, the spaceship could use solar sails for the majority of the journey before switching to pulsed nuclear propulsion for higher speeds in the final leg. It's also feasible that in the future, we'll discover even more advanced propulsion technology that we don't know about yet. What is the duration of the trip? The travel time to Proxima Centauri will vary greatly depending on the speed of the spaceship. In principle, though, reaching 10% of the speed of light would be sufficient to shorten journey time from several thousand years to only 44 years. The goal is to travel at 10% the speed of light. At such speed, the transit time to Proxima Centauri would be far more plausible, albeit explorers would have to spend more than 4 decades in space before arriving. Because the astronauts would need to be separated from the rest of the planet for such a lengthy period of time, this length of time offers considerable obstacles for the mission. One option is to board the spacecraft with at least 3 generations of astronauts, including adults, toddlers, and newborn babies. For half of the mission, the adult astronauts would be in charge of running the spacecraft, training the children, and caring for the newborns. The first-generation astronauts will age as time passes, the children will become adults and take charge of the spacecraft, while the infants will grow up to be children. The first-generation astronauts would have died naturally, or would be living their final years with limited mobility when the ship arrived at Proxima Centauri. On the other hand, those who left as children would already be elderly adults, and those who left as babies would be functional adults in charge of the mission, ready to explore a new solar system and find a home, some green and blue planet to start over. On our road to deep space exploration, we will encounter technical and scientific obstacles that will necessitate the collaboration and joint effort of many people and governments. However, we will encounter ethical and philosophical issues that will necessitate serious deliberation and profound thought about what it means to be human, to live a full and meaningful life, and to face our ultimate destiny. Space exploration reminds us that, while our horizons may be infinite, our time on Earth is finite. However, it also invites us to think, imagine, and embark on fantastic journeys that lead us beyond our wildest dreams. Finally, space exploration reminds us of the significance of living our lives to the fullest and making the most of our time on Earth.